Good morning, everyone. I am K. Narsimurthy, working as an assistant professor in the Government First Grade Women's College, Tumkur. I am going to present the video for the course BSc and the subject is physics. The paper which I am discussing is semiconductor devices, digital electronics, laser and fiber optics. The topic which I am discussing today is the black diagram of CRO. CRO expansion is cathode ray oscilloscope. Here we are going to understand the construction and also the working of cathode ray oscilloscope with the help of black diagram. So cathode ray oscilloscope consists of it's a CR tube. CR tube is a sensitive arrangement with which a transient phenomena of short duration can be detected and recorded. Transient phenomena means a very small changes which happens in the voltage or current. That small change, that small phenomena, small change in the phenomena can be detected, and also that phenomena can also be recorded with the help of CRO. So CR tube is a sensitive arrangement with which this small phenomena, that means to say transient phenomena of short duration, can be detected and also be recorded. This is the black diagram of CRO. When we go to the construction of CRO consists of highly evacuated glass tube, pear-shaped glass tube. Pear is in fact a fruit and it is narrow at the stalk and wider at the bottom. This tube is exactly like a pear shape. This is a pear shaped glass tube with a long neck. Here you can see a very long neck and a conical shaped body ending with a flat screen, ending with a flat fluorescent screen. This is a flat screen. This is a conical shape. So it has a long neck with a conical shape ending in a flat screen. Okay, right. So here the neck of this is closed by the cap and is provided with a terminal for various electrodes. Right. As I told you, it has a pear-shaped body with a conical body ending with a circular flat screen, and this end of the neck is closed by the cap provided with a suitable terminals for various electrodes. Right. Here the CRO consists of actually the four parts. The first part is the electron gun, okay, where the electron beam is ejected. Second part is the focusing anodes where the electron beam get focused, and the third part is deflecting fields where the electron beam is deflected with these two kinds of fields, and finally the fluorescent screen where the beam is recorded. These are the four different parts of the CRO. Coming back to the construction, the first part, the electron gun produces a narrow strong beam of electrons. Here is an electron gun. Here this F is an electron gun. From here there is a tungsten over here. When the tungsten is getting heated, the electron is ejected out of it. The electron will comes from this electron gun. Okay, that's the first step. If electron comes out of it, the next is the focusing. So electron has to be focused with a narrow beam with the help of three different anodes. We have three anodes here. A1, A2 and A3 anodes provide an additional focusing. These anodes will provide the focusing for the electron beam which is ejected from the electron gun. A1 is maintained at the 1000 volts and A2, A3 are about 2000 volts. This is the voltage of three anodes. Okay, I'll show you the three anodes here. This in the figure it is only two anodes which have been shown, and the third anode is not shown in this figure. Okay, right. We'll move on to the next thing. C is a control cathode, again that is not shown in the figure, and together with A1, A1 is a first anode, so control cathode together with the first anode forms a condensing lens. This is one condensing lens. And also A2 and A3, these are the two anodes, forms a second lens. Here we have two lenses, two condensing lenses, two focusing lenses. One is control cathode together with an A1 anode will forms a condensing lens 1, and A2 and A3, the two anodes, forms a second condensing lens. So we have a two lenses here. Two lenses are used to focus the electron beam which is coming from the electron gun. Now, by adjusting the potential of A3, A3 means the third anode, by adjusting the potential of A3, the focal length of a second lens can be varied. Because A3 is related to a second condensing length, we can vary the focal length of the second condensing length just by adjusting the potential of A3. Two converging lenses together produce a further focusing of electron beam which produces sharp tiny spot on the fluorescent screen. Now we have a two condensing lenses, they are focusing it additionally, and we have a narrow beam of electrons which produce a sharp spot, sharp tiny green spot on the fluorescent screen. Here is a speciality of screen. Screen is coated with a kind of material called aqua dog or willemite. Okay, the screen is coated with this kind of material as a fluorescent material. This is a fluorescent material, so any spot falls on this screen will be clearly visible. Now electron beam produces a bright green spot at the center of the screen. The electron beam which is coming from the electron gun, and after focusing this it produces a bright green spot on the fluorescent screen. Now the coating of the fluorescent screen is earthed. It is earthed because any tiny stray electrons outside the beam will flows down to the earth, but this should not affect my the waveform. So this electrons which stay outside my beam should goes to the earth easily, because that should not affect my waveform. That is why this fluorescent screen has been earthed so that stray electron flows to the earth. So next is the third part, which is an X plates. X plates mounted vertically, in fact X plates are mounted vertically, produce an horizontal screen. X plates produce an horizontal electrostatic field and deflect the electron beam in that direction. In that direction, in the sense, it deflects the electron beam in the horizontal direction. So X plate mounted vertically produce horizontal electrostatic field, deflect beam in the horizontal direction. I will show you with this diagram. Yes, look at the X plate here. X plates are mounted vertically and they produce horizontal electrostatic field and they deflect the electron beam in the horizontal direction. Now we have a Y plate over here. Look at this Y plate. Y plates are mounted horizontally and they produce vertical electrostatic field and they deflect the electron beam in that direction. It means stay in the vertical direction. Deflect the electron beam in the vertical direction. So X plate deflect the electron beam in the horizontal direction and Y plate deflect the electron beam in the vertical direction. With effect of these two plates, one horizontal and one vertical plate, so the electron beam will move in a resultant direction. Okay, the two fields at right angles to each other and to the direction of electron beam gives the spot. Now the spot is deflected in the resultant direction. The spot will goes in the resultant position. Now the working. Some of the workings which I already explained, the construction itself. Okay, formally we will see the working of this cathode ray oscilloscope. So electron gun, as I told you, produce a narrow beam of electrons, and these narrow beam of electrons are focused by the focusing anodes A1, A2, A3 along with the control cathode. And the two converging lenses together will produce a further focusing of electron beam, and a sharp spot is produced on the fluorescent screen. Now we have two fields here, two fields to deflect the electron beam. One is an two fields which is given to the two plates. One is X plate, another one is Y plate. These two fields, which are right angle to each other and to the direction of electron beam, deflect the spots in the resultant direction. Okay. And now the spot is seen on the fluorescent screen. Suppose if an alternating potential is applied to one set of plates, not to the two plates, only for the one set of plates. So let's say it is for the X plate. For the X plate, if I give an alternating potential means the potential which varies with time. The amplitude as well as the direction varies with time. Such alternating potential is applied to one such plate, one set of plates. The spot is drawn out into oscillating line. Now it is not a single spot. The spot is drawn into an oscillating line. You will get a waveform. You will get a complete waveform because now the spot is drawn into the line that gives a waveform. This happens only if you give an alternating potential to the one set of plates. Suppose if you give direct voltage, if you give DC, it will give you a straight line in the output. The spot is drawn into a straight line. Suppose if you give an alternating potential to one set of plates, it will drawn in the form of a wave. Right. The amplitude of that wave, amplitude of that line is proportional to the applied voltage, maximum value of the applied voltage. Suppose I am giving a 4 volts here, I should get an amplitude which is proportional to that 4 volts. Suppose if I reduce the voltage, your wave amplitude will get reduced. If I increase the supply voltage, the amplitude of the waveform will get increased. Anyway, the amplitude of the waveform which I am getting on the fluorescent screen is proportional to the value of the applied voltage, maximum value of the applied voltage. Right. Suppose in case if I give alternating potential to the two plates, both X as well as Y. In such a case, you will not get a waveform. You will get a Lesage's figure. Lesage's figure are traced on the screen. Okay, that's a special character here. That's a special thing here. If I give two waves, two alternating potential to both X and Y plates, you will get a Lesage's figure. It's in the form of ellipse, or it in the form of figure of 8, or it is in the form of 3 loops. Of course, you will have an horizontal, you will have an infinity symbol, horizontal 3 loops, you will get horizontal 4 loops, and number of loops you will get. And these are the Lesage's figures which we get on the fluorescent screen, provided you give a different alternating potential to the different XY plates of the CRO. Then of course there are many applications of this CRO, and that applications which I am going to discuss in my next video. So this is all about the construction as well as working of cathode ray oscilloscope. We learned it with the help of a black diagram of CRO. So these are some of the books. Fundamental Principles of Electronics by Vasudev Ghosh. It is published in 2014, and there's one book written by the Tumakuru University professors, Fundamentals of Physics, published in 2019, and we have a good old book called Malvino and Leach, the title Digital Applications and Digital Principles and Applications. Here is a very good book which I have referred particularly for this topic. The College Physics by Sundarajan. It is even an old book which is published in 2011. Of course, you'll get most of the figures and the text is available in the internet also. Yeah. So I hope you understand my video. Thank you very much.